All right, so I promised you a part two, so here's our part two. Okay. Now, in the first video, we looked at estimating. Let me get out a black marker here. So we looked at estimating a confidence interval for the population proportion P. All right, and I told you in the previous video, hey, I'm going to show you, or I'm going to explain the differences between the problems that we have. Like, in other words, how do you know you're trying to find a confidence interval for P? Or in this video, what we're going to be doing is estimating a confidence interval for mu. Okay, so let me just show you the difference here real quick. All right, so I'm going to pull up two problems and we're going to compare the two. Okay, I'm back, and here are the two problems. Okay, so with the first one here, it just says find a necessary confidence interval for the population mean mu for the following values. Now, I realize it's telling us to find a confidence interval for mu, but here's how I really know what's happening. Look at my sample statistics. My sample statistics, and I'll zoom in so you can see them, are n equals 80, which is the number of samples. That's normal. But they're giving me the sample mean and the sample variance. As soon as I see this sample mean right here, I know that is my best point estimate for mu. Okay? So I know for this problem, I'm gonna, no matter what, even if they didn't tell me construct a confidence interval, if these words were not here and all they said was find a necessary confidence interval for the following values, I instantly know I'm going to find a confidence interval to estimate the population parameter mu. And how do I know that? It's because of the sample data that they provided. Okay? Now, when we compare that with this problem, here is what is screaming out loud to me. This is screaming, hey, you are going to find a confidence interval. So let me write it out here. Confidence interval for P. And how do I know that? Because they tell me the number of successes out of the total sample space. So just to kind of reiterate or review, if given x bar s or s squared, you're estimating the population mean mu. Okay? If you're given number of successes, all right, or percent numbers, instead of like 95% or 99%, if they're telling you 50% of the population thinks this, or 82% of the people surveyed said this, that is screaming population proportion, which is P. And that's how you can tell the difference between what type of problem you're doing. Now, for the homework, it's pretty clear cut. Like, I'm going to tell you what I want. But for the quiz, I'm not going to say as much. I'm still going to give you a lot of information. And then for the exam on chapter 8, I'm not going to say anything. I'm just going to say create a confidence interval, okay? All right, so because we already did this one in the previous video, we're going to do the population mean, and it's going to be very, very simple, okay? I'm not going to go through all this stuff because we already did all the theory in the previous video. So what I want to do here is just, let's erase this, because I want to do this problem right here. I took this problem directly from your homework. So let's just go ahead. Let's do this problem. And we're going to do this one by hand, okay? So we want to find the necessary confidence interval for the population mean mu for the following values, okay? We want a 90% confidence interval, n equals 80, x bar equals 24.3, and the sample variance, remember that's the variance, okay, that is 3.76, all right? So step one, we need to verify requirements, just like in the previous lecture video. So the requirements here are very simple. One, the data is taken from a simple random sample. Oops. Or the second requirement, maybe I should be using A or B. N is greater than 30. So this doesn't tell us anything about how they sampled the data. However, N is 80, which is bigger than 30, so check. All right. Step 2. Find your Z alpha over 2. Now, the Z alpha over 2 is going to be the same as it was in the previous video. So because we want a 90% confidence level, our Z alpha over 2 critical numbers are going to equal 1.645 plus or minus, okay? Step 3, we're going to find, let me write the word find. Find the margin of error. Now, this is different because we're estimating a different parameter. Our margin of error is going to be different. So the margin of error is going to equal Z alpha over 2 times S over the square root of n, where your standard error is S over the square root of n. Okay? So for us with this problem, our margin of error is going to equal 1.645 times, now, here's the thing. They didn't give us this, they didn't give us S. If you look back up at the original problem, they gave us S squared. So we need to take the square root of 3.76. All right? So if you give me a second, I'm just going to use my calculator. Square root of 3.76 is going to equal 1.939071943. It's a bunch of numbers, okay? So I'm going to have to write that down up here. Oh boy, maybe I should have. I'm just going to use the power. I was going to say of the internet. If anybody knows who that is, who says that, you can email me and I'll give you bonus points. All right. So there's S over the square root. How many? 80. So when you go ahead and calculate this, 1.645 times, we got our standard deviation in the numerator divided by the square root of 80 in my denominator. I'm just using my calculator here. I come up with 0.3566275. And like I said, I like to keep as many decimals as I can. So step 4, let's construct our interval. Now the interval here is going to be the exact same as the previous. It's just a different parameter. So this interval is going to be x bar minus the margin of error, which is less than mu, which is less than x bar plus our margin of error, okay? So this is going to be x bar, which I completely forgot what it is already, 24.3. So it's going to be 24.3 minus 0.3566275, which is less than mu, which is less than 24.3 plus 0.3566275. Okay? So when I go ahead and just add and subtract my error, I need to get my calculator out one more time. 24.3 minus my margin of error is going to be, and I'm going to round it to 3 decimal places, okay? So it's going to be 23.943. And then my upper limit is going to be 24.3 plus my margin of error, which is 24.943. 0.657. And once again, like I said, I rounded to 3 decimal places. So if I zoom out and just compare my answers with the ones that are listed, 24.943, check, and 24.657, check. So I'm good either way. Now, we interpret this number, and we interpret it the same way that we interpret everything else. We are 90% confident, because that was our confidence interval, that the true population mean, because that's our parameter in this case, so the true population mean is contained in the interval of 23.943 to 24.657. So that is the way I interpret it. Let's see what your homework, how they interpret it. We are 90% confident that the population mean is within the interval. Well, that's really boring. I tell you this, if I were the boss and my employee said we're confident, 90% confident that the population mean is within the interval, I'd fire them. I'd be like, what are you talking about? I don't know what that means. I hired you to do the math because I can't. Give me numbers, but you lucked out. You lucked out with clicking or selecting very easy problems. All right? So that is how we do this, okay? So what I want to do here is I want to do one more, except with this one, I'm not going to just give you the numbers, all right? What I'm going to do is I'm going to, excuse me, it's going to be an actual problem, okay? So give me a second. I need to copy and paste some stuff. All right, I'm back, and here's our problem. So this is just a straight-up word problem now. A supermarket chain packages ground beef using meat trays of 2 sizes, one that holds approximately 1 pound of meat and one that holds approximately 3 pounds of meat, okay? A random sample of 37 packages in the smaller meat trays produced weight measurements with an average of 1.01 pounds and a standard deviation of 0.11 pound. Suppose that the quality control department... Oh, I forgot the most important part. Let me pause it because I need to copy and paste again. Okay, I'm back. Sorry about that. So the first thing we want to do is construct a 99% confidence interval for the average weight of all packages sold in the smaller meat trays by the supermarket chain. Make sure you round your answer to 3 decimal places. And then the follow-up question would be, should the quality control department of the supermarket chain... suppose the quality control department of the supermarket chain intends that the amount of beef in the smaller trays should be 1 pound on average. Should the confidence interval in part A concern the quality control department? Explain. All right. So let's go ahead. Let's do this problem. So first things first, we got to know what type of interval we're creating. So when I read the problem, and I'm going to highlight the important pieces of information, and it's right here. A random sample of 37 packages in the smaller meat trays produced measurements with an average, so forgot the word measurements, average of 1.1 and a standard deviation of 0.11 pounds. So I know from here, okay, that this is going to be a confidence. Oh, I need my other marker. I need my confidence interval for mu. And how do I know that? Because they're giving me the sample average, X bar equals 1.01, and a standard deviation. Now, if they're giving me the sample average, then this is the sample standard deviation as well of 0.11 pounds. Okay? So I know confidence interval for mu. So number one, our sample is 37 packages, so it satisfies the conditions that we need. Step number 2, let's go ahead and find Z alpha over 2. Well, since they want a 99% confidence interval. Oh, sorry, I read the wrong number. 99% confidence interval. That means my Z alpha over 2 critical values are going to equal plus or minus 2.575. Okay? Now the next step, let's calculate that margin of error. We know the margin of error is going to be Z alpha over 2 times S over the square root of N. So my margin of error is going to equal plus or minus 2.575 times, now they gave us the sample standard deviation, which is fantastic. So it's going to be 0.11 divided by the square root of 37. Yeah, because we had 37 packages. So if I get out my calculator and just go ahead and type that in. So give me 1 second here. So I'm going to type that into my calculator. 2.575 times 0.11 divided by the square root of 37. I get 0.046566. Remember, keep more decimal places than what you need. So finally, my confidence interval, x bar minus my margin of error, which is less than mu, which is less than x bar plus my margin of error. So the only thing I need to do is just go ahead and calculate this. So the mean was 1.01 minus 0.046566, which is less than mu, which is less than 1.01 plus my margin of error, which is that big decimal number again. So 1.01 minus my error, rounded to 3 decimal places, it's going to be 0.963, which is less than mu. And then my upper limit is going to be Well, I don't know why I'm telling you sorry. I hit the wrong button on my calculator, so I said sorry to myself, which is kind of funny when you think about it. So my upper limit is going to be, rounded to 3 decimal places, 1.0, what is that going to be? 7, I think. All right? So right here is our confidence interval. Okay? And we're 99% confident. So we are 99% confident. All right. Now, I know, excuse me, your homework, the way they interpret this is it's boring. I'm going to give you the real way. So we are 99% confident that the true mean weight of 1 pound container, or 1 pound, we'll say meat container, or meat packages, lies between 0.963 and 1.057 pounds. Okay? Now, the follow-up question was, suppose that the quality control department of this supermarket chain intends that the amount of ground beef in the smaller trays should be 1 pound on average. So quality control is walking up and saying, hey, we intend that when somebody comes up to our counter, they grab a package of meat, our intention is 1 pound. All right? Should the confidence interval that we just calculated concern the quality control department? And the answer to that is no, it should not concern them, and here's why. So we should not be concerned. And the reason for that is when you look at the confidence interval and you compare that to the number 1, the quality control department is saying all the packages should be 1 pound. But we know we are not perfect individuals. But if we are 99% confident that the true mean weight of 1 pound packages is in between these two numbers, and notice 1 is in between those two numbers. So the meat department should not be concerned. They shouldn't change anything. Let people do their job. However, if our interval turned out that 1 was not contained inside of it, then the meat department needs to be concerned. Somebody's not doing the job correctly, or maybe the machines are not doing their job correctly. Like, when you weigh the meat, maybe the scale is incorrect. Personally, I would check the scales first. I honestly think people do the right job the right time, or the first time. Sometimes the tools aren't good enough. Sometimes they break over time, and that happens. It's a thing. All right, so that is going to be it for this video. I hope this makes sense in terms of creating confidence intervals and everything. If you have any questions, please do not hesitate to ask me. This can get very cumbersome very quickly. On one final note, there are certain questions that ask something like, how do you create a larger or smaller confidence interval? I want you to try to work with the numbers and figure that out on your own. The idea behind it is, remember, all this goes back to that fishing example, okay? If you throw your rod into the lake and you catch one fish, is that one fish a really good representation of all the fish? The answer is no. So we create a net. The question becomes, how big of a net do you want? How can we control how wide or how narrow that net is going to be? And there are ways to do that, and you know what they are. All right, you just got to think about it. We're only concerned with population and statistics, and then sample size and confidence intervals and confidence levels. So think about it. If you need a push in the right direction, all you got to do is just let me know. Just send me an email. All right, talk to you later. Bye.